Good afternoon and welcome. I'm Brent Donaldson, Senior Editor for Modern Machine Shop and for Additive Manufacturing Magazine. Today's webinar, brought to you by Velo 3D, will cover the cost and time benefits directly related to the elimination of support structures in metal 3D printing. While these benefits are far greater than many understand, they are often insufficient in strengthening the business case for metal 3D printing, and they fail to capture the real business impact that motivates decision makers. Today, we'll hear firsthand accounts from our panelists on the impact that supportless metal 3D printing has had on their businesses. From two divergent viewpoints, including a precision machining services company and a manufacturer of rocket propulsion systems, you will learn what support elimination can do for your product designs, manufacturing operations, business growth, and product innovations. Armed with these insights, you will be better equipped to make a strong business case for metal 3D printing. Today's presenters include Todd Grimm, President of TA Grimm & Associates, Mike Corliss, Vice President of Technology at Knuth Godwin, Jeff Thornburg, President of Interstellar Technologies, and Richard Neesett, Chief Customer Officer for Velo 3D. Please note that you can submit questions for our panelists at any time during this presentation. Just type your question into the questions box and we'll answer as many as we can at the end. Also note that this webinar is being recorded and you will receive a link to that recording via email. With that, I will turn it over to Todd.
Well, thank you very much, Brent. This is Todd Grimm. I will be acting as moderator for this webinar. And my role in the industry, my own company, TA Grimm & Associates, which does consulting and additive manufacturing. Personally, I've been in the industry for 30 years. And the reason for me acting as moderator is I am the author of the white paper by the same title as this webinar. The white paper was conceived because so many people stop short of the true advantages of a supportless or support elimination process for metal additive manufacturing. So the goal was to elevate the conversation to a higher level, to an executive level, to help you build a business case. And what we're going to do today is we've got two of our contributors to the white paper as panelists, and our goal is to have a richer commentary on what they've experienced, what their insights are on situations where they can eliminate supports to help you gain insights that you can use for your business case, and even to spur some thoughts and ideas that go beyond the straight time and cost equation that so many operate under. So with this, it's going to be a dialogue, a conversation amongst the panelists that I will be guiding. And with that, I want to have our panelists introduce themselves, starting with Mike Corliss, and we'll proceed from left to right as you see on the slide. Mike, would you give us a brief description of the company and yourself so people can understand where you're coming from?
Yes, my name is Mike Corliss. I'm the Vice President of Technology at Knuth Godwin. I've been in manufacturing for over 39 years, and we're a subcontract manufacturer company, and we started additive manufacturing 8 years ago here at the facility.
Mike, was that additive manufacturing in general or specifically metal additive manufacturing that you've got 8 years experience?
Metal additive manufacturing.
Thank you. Jeff?
Yes, my name is Jeff Thornburg. I'm the President and CEO of Interstellar Technologies based in Huntsville, Alabama. We're a space technology and engineering company focused on spacecraft platforms and propulsion systems. I have a 25-year background in spacecraft engineering and propulsion that dates back to the Air Force. I've worked in private industry for both established and new aerospace companies and supported various NASA programs. Worked very closely with Elon Musk and Paul Allen in my career as well, and appreciate the opportunity to be here today.
Well, thank you. Richard.
Hey, everybody. This is Rich Neesett. I'm the Chief Customer Officer for Velo 3D. I have about a 30-year background in product development and product management, but unlike Mike and Jeff, a relative newcomer to additive manufacturing, I've been with Velo 3D for a little over a year. And I wanted to join Velo really to kind of see that this promise of being able to make additive disrupt the supply chain a reality. And over the time here, we've worked hard to do just that. We're looking at cases like direct part replacement and improving individual part performance and trying to figure out how to make sure that we can deliver on the capabilities necessary for those business cases to become a reality. It's turned out that while we wanted to just hit the print button on so many of these parts, it actually hasn't up until now been really all that easy. And the idea of eliminating the support requirements that have been holding us back and advancing the industry with a better business case has started to come to fruition. So we're all about trying to figure out how far we can drive that into production.
Excellent. Excellent. Thank you, gentlemen. And I do want to recognize the 4 other contributors to the white paper. Those were Chad Robertson of Hanwha Power Systems, Scott Volk, who in the interview process, he was representing Encodema 3D. He's now with a company called CAM, Kisilowski Additive Manufacturing. We also had a contributor from Proto Labs, David Bentley, and finally Andrew Carter of Stratasys. So that white paper will be provided to you via link following the webinar. We encourage you to read it. So just want to give you an idea of who contributed and where the conversations and insights were coming from. Now, before we dive into the dialogue on the advantages of a supportless or support elimination metal additive manufacturing process, I want to make sure we're all on the same page. And that's a brief description of supports. So we're talking specifically about powder bed fusion, laser powder bed fusion, metal additive manufacturing systems. For metals in the PBF category, we do require supports, unlike the polymer solutions for powder bed fusion. And the reason is illustrated here in these images. This is courtesy of Proto Labs. So we have a flat plane and a cantilever plane attaching to it at 50 degrees. So generally, the rule of thumb is anything below 45 degrees, you want to have support structure underneath that feature. So at 50 degrees, we're looking pretty good. At 45 degrees, if you look carefully, you can start to see a little bit of surface roughness increasing. At 40 degrees, that surface roughness is now very obvious. At 35 degrees, it degrades even further. At 30 degrees, if you look at the far right lower edge of that cantilever, you can see that it's actually bowing downward. And then at 25 degrees and beyond, incapable to build a part. So support structures for the vast majority of metal additive manufacturing systems in the laser powder bed fusion class requires support structure to physically build a part. Now that impacts the business, that impacts technical aspects, including doing parts without redesign. So these are some of the advantages. Pictured on the upper right is a CAD model where the red represents what would need to be supported. The image below is a 3D printed, additively manufactured part that was done without support structures. By eliminating supports, you're able to produce parts without redesign. And we'll be discussing that in greater length as we go further, so I'm not going to elaborate. It also allows, in the redesign category and in general what you can do with your designs, it enables geometries that aren't possible or severely impacted by support structures. And we mentioned overhangs, so 0 degrees is possible. Thin walls can be problematic with supports. Large inner diameters, bores that aren't in the vertical plane, can require support structures that need removal, and things with high aspect ratios. And that's just a start of the list. But those are impacted by support structures, so the advantage technically is that by eliminating them, we now can do these features and get the quality out that we want. And the bottom line that so many people stop at in concluding what the benefits are straight up cut the post-processing time and cost. And those are real benefits. Those drop to the bottom line. They're impactful. However, as we found in the white paper, those benefits are short-sighted. They fail to see the higher level business advantages that can really drive a decision to incorporate metal additive manufacturing. And that's where we're going to go with this conversation. Now, how predominant is this? Well, according to Proto Labs, prior to having a support elimination capability, 95% of all the parts that passed through their operation required support structures. So nearly 100%. And the impact in their mind was that support structures are one of the biggest constraints in metal additive manufacturing. They cost time, quality, and innovation, and the business advantages of support-free are numerous. But I want to really focus on that word constraint. That's the key here, eliminating constraints that hold back your business opportunities, whatever you want to do with metal additive manufacturing. Now we're going to open it up to the dialogue, the questions, or not questions and answers, the dialogue period amongst me, Mike, Jeff, and Rich. And I want to start with high-level question for Mike and Jeff. What motivated you to look at a supportless process? And or you can answer this two ways. You could also tackle this by what have you been able to achieve with a supportless process? And please raise this conversation up to the highest level. Summarize as best you can the advantage that you've recognized, and we'll get into the details through the questions that I'll be posing to you. So, gentlemen, I don't care who would like to start. So please, one of you take the lead on that question.
Well, this is Mike. I'll start off. Is that we wanted the ability to print more complex geometry products with lower angles with little to no supports compared to the traditional limitations, because those limitations held us back from the product being successful or not, or winning the bids or making it cost competitive. So those are key things that drove us into looking for supportless builds.
Yeah, this is Jeff. I think what I would start by saying is that, you know, over a decade ago, when I started looking at additive for the propulsion industry in particular as a part of rocket engine development, I think the main thing was we were looking for ways to grossly accelerate and lower costs to commercialize the space industry. We hadn't yet seen the success of companies like SpaceX and others. And really what motivated to look at these processes are the things that were mentioned earlier in Todd's intro, but ways to speed new designs and new innovative approaches to the problem. The time frames alone for something with geometries as complicated as rocket engine hardware used to be incredibly extreme. And once we got into some of the initial years of playing with additive for these types of processes in my industry, the motivation really became a realization that the constraint to our process was not the printing of the part. It was how do you get that part in its final configuration to use it in your development program and your flight program. And I think that's really the reality here that's been mentioned a couple of times, is the motivation truly is everybody thought when we started this journey with additive that it was put it in a machine and print the part and it's ready to go. And that's not really the reality. So the excitement now today with what's happening with Velo 3D and the Sapphire machine is these supportless processes that really kind of bring that ultimate future to life of printing a part and having it as close to being ready for utilization in your development and production programs.
Excellent. Well, Jeff, on that, you mentioned one word. I want to call that out. When we talked, you really boiled it down to innovation was the key. That was the highest level advantage or win for Interstellar. Is that what you're saying and elaborating on?
Yeah, for us, the focus is right now really squarely on two things. Innovation is key, and innovation related to speed of bringing those new products and new designs to the customer, to our customers. So when you're unconstrained, like you are in these supportless processes, it opens up a new way to thinking about design. And that's what's exciting for us at Interstellar, is that we truly design for additive process is in mind from day one. There is no other way to build our hardware, and that's what's so exciting about the results from what we do every day with what we're doing for our customer community.
Excellent. Well, and Mike, I want to go back to you too. You opened with winning bids due to cost and time. When we talked, you'd actually raise that to an even higher level of opening the door to new industries that you can, if not effectively serve, that you can serve well. Get your foot in to an industry that you've not been in before. Is that still true?
Yeah, absolutely. I mean, it's opened the opportunity to go in and take existing products and also new developed products in order to take and print those successfully. And when you're competing out there, you're having to really look at every little bit of the supports add cost and time and money. So you're really looking at all of that as a factor in winning that bid in the different industries. So every little bit counts.
Excellent. Thank you for the elaboration.
Hey, Todd, this is Rich. If I could just jump in on Mike's thought there for 1 sec. One of the things
Please.
that I'd like to point out with regard to innovation too is that, there's innovation on the design side, which we love. And no question, Jeff's team is really pushing that envelope, but there's also supply chain innovation. So if we can really get past the constraints and get to the reusability of the parts, then we can open a lot of innovation about how we run our business through the supply chain.
I kind of glossed over this. So how does support elimination eliminate a constraint? Mike, you said, time and cost, but is there also a concern of just the practicality or possibility of removing support structure after the fact?
Oh, yeah. As a contract manufacturer, we would love to have every product designed for additive manufacturing, but in reality, it's not possible. There's not enough time, money associated with, engineering's having to go back and develop and redesign the process. So the ability to print the product as is with legacy products is real key to us. Like I said, we would want to have everything designed for additive to take advantage of a lot of the technology, but as a contract manufacturer, we have to be able to take what's there and the existing stuff and go with it, print it and go.
Excellent. Well, Mike, you are playing straight man for me because our first topic that I want to cover is design. So those joining us, we're going to look at unshackled designs in two contexts. One is creative, complex, novel geometry that may not be possible with traditional manufacturing processes, but the other is a direct translation from using a design that was crafted for a traditional process. But I want to start on the first one, the complex, the novel, along the lines of those beautiful images we see online or in articles that are just mind-blowing with what's possible. Now, the format I'm going to use here to bring in other conversations from the white paper is to use some quotes from the white paper as a foundation for the conversation. So here on screen, you can see, and I'm going to read it for you. I can print with the geometry that I want to use, rather than use a design that compromises aerodynamics, but is AM friendly. Now, this is coming from Chad Robertson of Hanwha, and what he's talking about here is optimal performance without constraints or limitations. And the background on that is he's talking about running things through CFD, computational fluid dynamics, to come up with the optimal design to yield the performance that they're looking for in a non-additive or an additive with supports. They oftentimes found that they couldn't achieve that optimal design. It just wasn't possible, so they'd sacrifice some performance. So you've already elaborated on this, Mike, a lot, and Jeff somewhat, but we talk about additive, or it's been talked about in the past, unlimited freedom of design. Do you believe that support structures are the key limitation to that statement not necessarily being true? And if you can expand on that and say, why? And if you have any examples, like a typical part category, love to hear where you bump up against that most often.
Well, in the oil and gas industry, we see that a lot of designs are always having to be modified or altered for flow, mud flows and things. And so you're limited to what a manufacturer's capabilities are, and the ability to print an organic design or a shape that is for the optimized shape sometimes would require to have supports in there, but the ability to print it without supports is going to open it up tremendously. So the engineer has the freedom and the ability, the control's back in his hands now, and he can design the part like he wants and not worry about how are we going to manufacture it and the cost of manufacturing it, because we don't have to remove tons of supports.
Jeff?
Yeah, I guess the example that I keep coming to in my mind is when you talk about impellers for turbo machinery specifically, you know, many years ago, the only way to produce a shrouded impeller was to, you know, have a very complicating machining technique that really limited your ability to use anything but a certain set of geometries wherever the cutter could actually reach, and really how the tool was set up. And then with additive, the onset of that technology, the geometries got opened up a little bit, but then you were restricted by the fact that you exceeded certain angles, as mentioned earlier, and you require support structure. And then you have to then go in and machine that support structure or try to remove it, which affects surface finish and flow conditions. And so now we're like on the third generation since I started building rocket engine turbo machinery hardware and these impellers, where now with supportless technology, now you really do have an unshackled freedom of design in terms of that impeller geometry and the flow path, because now it was better with some supports, and now it's even almost to the extreme goal of creating whatever design you like. I don't know that we're completely there from a completely unfettered, unshackled design engineer standpoint, but I do think it's a good place to point out the fact that companies like Interstellar and teams like what we have, you know, to make this successful, you really have to change the way you think about designing a part, because it's not just that the technology exists, it's that you're really thinking differently about how to enable that design. But I do think impellers are a great example of how we've gotten 80 to 90% there in terms of unshackled design flexibility.
Now, you said impellers there, but you also said shrouded impellers earlier. So is that conversation just offered more towards the shrouded impeller, where my vanes are actually encapsulated between a lower plate and an upper plate?
Yeah, that's a great point, Todd. I mean, for clarity, shrouded impellers are the more difficult impellers for a pump design. Unshrouded means, you know, you don't have that cap on the vane, so you can get in there and machine with ease. But really, the shrouded design is where you couldn't. It's very challenging to get in there and machine those flow paths in that high performance shrouded configuration. And that's really an area that's been key in the rocket engine business in terms of increasing the speed of getting those parts and dramatically reducing the cost.
Actually, one of the other contributors to the white paper stated that shrouded impellers have been the holy grail for additive in their eyes, and that supportless process opens the doors to doing that. So a lot more work in shrouded impellers with respect to metal AM. Now, Mike, you played straight man for me, because the other aspect of design was the ability to do a direct replacement. What I mean by this is, and I've got your quote up here, we can finally print the part as is, which you said in your opening statement. This is about taking a part that's been designed for a traditional process and being able to pull it into an additive space without redesign. In the white paper, a couple of people made the statement that this was a big constraining factor towards general adoption of metal additive manufacturing, because we're forcing people to learn how to accommodate for supports and to change the design, and B, just the time and effort to go back in and redesign just so you can use this process that you want. Mike, I'm going to turn this to you, because I've got your quote up here, and you're dealing with customer requirements as opposed to your own internal. How often does that happen? I mean, let me back up. Do you think that a constraint on adoption is forcing people to redesign the parts just to accommodate additive?
Well, overall, I think everybody's learning and starting to understand more and more about additive, and we try to do a good job of educating our customers and how to apply additive. But over 90% of the products we see are traditional products that were designed with traditional manufacturing processes in mind, and we come to them with the ideal of using additive so we can reduce costs and reduce lead time. So there's a lot of conversation going back and forth of how can we apply additive to it? Do they have the time to go back and adjust the models or designs? And quite frankly, a lot of time, they don't have time. They're always focused on the new thing. And so looking at legacy, so you're dealing with supply chain people that aren't the engineers that designed the part 5-6 years ago. You're dealing with supply chain. So it's very difficult to go backwards. So you have to have the ability to print as is. And that's key, to just take the design, offer a lower cost and quicker lead time product.
Excellent. Excellent. I'm going to move on to the next topic unless I've opened up another comment that either of you would like to make on design. If not, we're going to move forward. Next bucket is repeatability and reliability. What we're talking about here is the ability to confidently produce your first part in metal additive manufacturing. The other aspect is to reproduce that part time and time again without deviation. Quote I have here is from Andrew Carter of Stratasys Direct Manufacturing, and he stated that poorly conceived support structure strategies can cause build interruptions, build failures, and poor part quality. A supportless process reduces the human element of post-processing and increases reproducibility. Mike, I'm going to keep you in the conversation right now because you made a comment about as soon as the human hand touches a part, those two things go out the window. Can you elaborate?
Absolutely. You know, we hate adding supports to any product because the support removal process is very lengthy, and sometimes it's a manual operation. It's not always a machining operation. So you're relying on human hands touching the product, deburring it, grinding it, shaping it to remove the supports. And you know, when your next operation may be in a fixture that supports that part and you're doing the post-processing to it, those deviations of hand working it on some of these generic shapes can cause problems and the repeatability. So yeah, we want to try to eliminate these supports so we can make the process run smoother through the facility.
Yeah. Have either of you been witness to total build failure because of, as Andrew was talking here, a poorly conceived support structure strategy?
Absolutely. I mean, it happens more times than not, especially with a new build and you don't have the support structure process worked out quite right, and while you're building, the supports can cause the build to fail and you have to start over.
How bad does that hurt?
Oh, it hurts. I mean, especially, you know, the whole point of additive manufacturing is speed. And so when you're in the build, and especially if you have a part that has a configuration where you have supports coming from the build plate really high up and you have the failure towards the end of the build when you're almost complete, that's very discouraging.
Jeff, have you had that situation?
Absolutely. I mean, especially with, you know, being a little bit on the flip side from Rich, I think the main thing here is that in development, we often see build failures because we're doing something new and something different. I'd also comment that a lot of times that when we start this process of design, a major step in that process itself is the fact that we have to set aside time in that iterative process to really look at how the support structure interacts with the design and a successful build. And so, you know, that's just another aspect of a typical design flow where if you can remove that whole conversation and iterative process where you are going to see a failure and need to come back and revisit the support scheme, it goes right back to the cost and time and schedule equation.
Okay, it just impedes flow or forward progress. Now, guys, a very specific question. We've got software out there to automate the generation of support structures for metal additive parts. Why? Well, do you, and if so, why not, do you give 100% confidence into what comes out of a software program with a supported part for metal additive?
Yeah, this is Jeff. I mean, I would jump in and say I do not have like 100% level of confidence. I still see that as a constraint, right? So it's more of a negative connotation to what a business wants to see in terms of timing and execution. There's still no perfect software tool that's going to give you the right support structure and methodology the first time through, especially on complicated geometries. So maybe there's simplified part structures and geometries where you are 90 to 100% good every time, but certainly on the innovation side of that equation, where you're pushing beyond the state of the art, you're pushing for higher and higher levels of performance and lower mass targets. I don't see that level of refinement in the design tools today, and certainly it's an area for improvement.
Yep. One of our other contributors to the white paper made the statement that they let the automated process, the software, do about 80% of the heavy lifting, but the last 20% is performed by humans for the same reason you're saying, Jeff. And then they commented that also means now you need to develop that tribal knowledge on what an effective support strategy would be for that unique geometry. And it's a rather big ask. Not everybody can do it. And certainly people can't do it right out of the gate when they start with the process. I'm going to move on to productivity and process gains. And this applies to a lot of different areas. In the white paper, Mike, you mentioned engineering efficiency, more productive. And then you got your quote here: we don't have to worry about going to manufacture, remove supports or fixture apart, which you've already made that statement. Others commented that it improves the productivity of manufacturing engineering, lets them do the job of process refinement versus assisting people with an individual part. Others mentioned sales efficiency and productivity gains, not having to ask people to redesign to get to quotes, and then certainly with manufacturing because we're eliminating a step in the process. Now, on the surface, this is a straight up time and cost consideration, which I said we're not going to discuss. How does this translate for both of you to a higher level business win or business impact on the productivity gains and process gains? Is it doing more with the same amount of assets, both human and capital assets, or how does it play out for your companies?
Well, exactly, it does, and it opens up the portfolio of products that we can do for our customers. So this is a big gain for us. The more we can do for them, the better it is, and everybody wants to drive cost reduction and lead times, but being able to get these productivity and process gains just means more throughput and shorter time to market. And so this is really a big key for us, is that we don't have to spend so much time working on the process of removing the additional supports and things.
So, I think you commented in the white paper that was it 60 or 70% of your metal AM parts go through CNC operations. But as a shop that is a contract manufacturer, those CNCs are highly priced, highly valued because they're generating income. So can I assume that also by eliminating support structures, not consuming the time of a CNC, that now lets you have more sellable time on a capital asset, your CNC machine? True.
Yes, the products, I would say more than 60% of our products goes through CNC machines just because of the nature of the products. But yeah, it's just on the machine shorter, so the throughput is quicker, and so your capital is being utilized other places, and because we're only doing some very minor post-processing where you left stock on the parts, but it still has to go through a CNC machine, so your capital has more freedom to do other products, not spend as much time on other machining.
I'm going to maybe stump you, Mike. Is there any chance that you've had a situation where you guys were thinking you might have to acquire yet another CNC to handle your current workload, but you've paused for a second and say, you know what, we've now opened up that capacity, we can delay that purchase? And no is a fine answer on that. I know I'm catching you off guard on that.
No, it's a valid question, because a lot of the products we do requires, with all the variety of products, you have to have a large variety of some of the same equipment. But with additive, being able to remove a lot of those processes in-house now, and you can print majority of those shapes and details in a part. You're not required to have as much CNC or other ancillary equipment to go along with finishing the products. It really takes out some of the complex machining. I mean, you can add the complex machining geometry into the printed part, and what you're doing is some of the basic, simpler machining that you have a vast variety of equipment in the shop to do it.
Right, so a general purpose 3-axis mill might be able to do the job instead of an expensive 5-axis.
Correct, absolutely,
Okay.
in a lot of cases.
Jeff, on productivity and process gains, you talked rather extensively about the lead time to go after the print is done through getting a part through inspection. Can you walk us through that and the productivity and process gains by removing support removal as part of your standard operating procedure?
Yeah, sure. I mean, I think to me, the way I boil it all down is I boil it down to touch labor, right? Aerospace is traditionally plagued with these huge bloated costs in their programs and projects because of just the sheer amount of touch labor involved with these very high performance, highly tolerant systems. And so when we talk about printed parts and post-processing time, once the part leaves the machine and it's supported in a certain way, and then you have to remove all of that, and then you have to address the final surface finish and tolerancing and interfaces. There's more time involved in that process, as I mentioned earlier, than the actual print of the part itself. So by taking the support removal and the support scheme strategy out of that, both the design loop and now out of the manufacturing loop post-print, now you've really shrunk that time down and really and decreased that touch labor cost that's been kind of alluded to, where at least in my world in aerospace and space in particular, I'm focused on cutting out that touch labor to the maximum extent possible, and that's really where I see the gains for us at Interstellar.
Excellent. Any other comments on productivity and process? If not, I'll move forward to business expansion.
Yeah, if you have one more second, Todd,
Sure.
What I would just add to that is both Mike and Jeff are touching on the exact point that I was trying to make earlier with regard to supply chain flexibility. If we can remove these production constraints on additive and the downstreams and make an overall better business case, then in both examples, for Jeff as the OEM or for Mike as the contract manufacturer supplying, they've got a bigger portfolio of parts that they can now respond to. And it makes it possible for senior procurement officers and people that are, working on products that have long life cycles that need to, be able to supply limited numbers of parts. They now have flexibility to go somewhere and get parts they would not have been able to get, or they would have had to incur extremely long lead times or extra inventory or cycle times to be able to get at. So it's just underscoring that the productivity is starting to drive this business change.
Excellent. Which really talks to business expansion, our next topic bucket. Mike, another quote from you. Mike, you were quotable in this white paper. That's for sure. If I can provide my customers with lower cost and faster throughput, that is key. Key to what? So if you can elaborate on the business scenario Knuth Godwin was in and what you were trying to do, help us understand how those two benefits are key to what you were trying to do.
Well, we're looking for a game changer in providing our customers with an alternative manufacturing process. And the metal additive has been key to us as far as being able to, shorten these lead times and reduce cost. We've gone through a huge downturn in the oil and gas industry, so there's a lot of focus on cost and lead time. Everybody, time to market and, the design process, from conception to commercialization of a product. Some of these oil and gas companies that we're traditionally involved with, you may miss a cycle with a new product coming out. So being able to provide a customer with a new product design quickly that they can get to market faster, start generating revenue, could be, it's key. It could be a big difference for them being successful or not. So that's what we're focusing on. We want to grow that business to be able to provide more of our customers with that capability.
Excellent. Jeff, I'm going to leave you alone on this because you're innovative and going after your own, look, business expansion is inherent in what you're doing because it's a emergent segment of the space industry. But you can assist me with commentary along these lines. So this is a quote from Protolabs. There are big, high-value parts that can only be built with a supportless process. Big is an operative word there because the smaller the part, the more you can get away with, the more leniency on your design strategies. High-value parts, obviously, that's something that you want to target with additive manufacturing. And the question I have for you, Jeff, is with supportless or support elimination, have you seen any expansion of the variety of parts, so the AM applications within Interstellar? And so what kind of parts? You mentioned shrouded impellers already, but is there a segment of part category that you really weren't able to handle well when you were forced to have a supported 3D printed part?
Yeah, I think there's several that come to mind, but for this conversation, I think I guess I'd like to start out more in general and say any sort of part in the technology sector, and specifically say rocket engine sector, where you really need a encapsulated capability, meaning you can't go back and tweak the surface finish or change an angle or a geometric feature, because by the nature of the way you want to use additive, you can't get back in there again. And so I think that's the category of parts in general that's opened up in recent years, where with technologies that have been brought on board with the Sapphire machine, you can now fully print your part with not needing to worry about coming back inside highly critical features, because you'd never be able to get to them anyway. And then that allows you to actually make something as a single piece part versus multiple parts and then fastening them or welding them or joining them together in some fashion. I think that's really one of the real exciting areas. And on my team, I kind of call it a fire and forget. It's truly, you're printing your whole capability in one shot, and maybe you're having to clean up the machine interfaces, but that's really where we want to go. And I think, my interpretation when you say big, high value parts may not necessarily be in size per se, but some of these, the machine time alone, in terms of how long it takes you to produce, how many days it's going to take, there's a lot of time and cost involved in that, and you can only really generate some of these design features through these additive processes that are now been unlocked through surface finish enhancements, alloy development, and laser development, et cetera. So that's where I see the expansion of new types of parts, that it just doesn't require you to have to worry about going and back and tweaking anything before you're ready to go utilize that in a larger system.
Excellent. Now, Jeff mentioned, he threw out the name Sapphire for our audience. That is the name of Velo3D's metal additive machine. I'm going to extend this question just a little bit. You tossed out welding and other joining techniques. Beyond the time and cost, are there any other advantages for Interstellar to avoid having to make two components, be it additive or traditional, and then welding them or joining them some way?
I mean, to me, especially in an industry like spaceflight, reliability and safety are number one, right? And so reliability and safety directly correlate to part count. So anytime you can remove features and combine part count, you're getting tremendous value in the space industry in terms of these reliability and safety enhancements, and then also cost and time. And like I said before, with touch labor, every time I touch a part, and if I have more than one, all of those interfaces, everything that has to be touched up to certain finish levels, et cetera, just is time and cost. So this part combination capability of additive, and where it keeps innovating with the types of capabilities we're bringing online, that's where I see the value.
Excellent. What we're going to wrap up with, the last bucket is Jeff's hot topic, fueling innovation, and we actually have a quote from him here, pulled from the white paper. We're applying time that would be spent on designing around a limitation and applying that to creativity instead, which leads to better performance. Jeff, can you elaborate on that? How that feeds into innovation?
Right, you bet. I mean, this is obviously my favorite topic. I've spent my whole career figuring out new ways to innovate technology for space and propulsion applications, and that's why I've been so excited about additive for years. But when I'm building an engineering team and an organization, and we're talking about our process for bringing our, I guess to put it in another way, if I pause, the most satisfying part of being an engineer is taking what's in your mind and making it reality. And I think the additive technology that we're talking about takes us just another step forward in a faster way to turn those ideas that you have into something real. And if I don't have limitations in my way, and so what happens a lot is you'll come up with a great group of folks like we have at Interstellar, you'll come up with ideas, and sometimes you just have to throw some of those ideas away because they're just not possible yet. But when we're talking about supportless technology in particular, now we're taking a few of those limitations that we had before and just throwing them out the window, and now can really think further outside the box. And I think that's where we really specialize, is not the cliche out of the box thinking, but really reprogramming the whole way an engineer thinks about design. Traditionally, engineers are thought of folks that are more left-brained, intellectual than right-brained creative, but I have to tell you, the talented people that I've been able to work with over my career are very, very much creative, and additive has been a great playground to unlock that creativity, and has lended itself to see incredible performance and productivity gains for all of the people I worked for in my career, especially in the last decade, and now our own team at Interstellar.
Awesome. Yeah, I guess nothing would be more disappointing than having a very creative mind shut down left and right every time he comes up with a creative idea. Kind of takes the steam out of the whole flow and that individual's enthusiasm. And
well, it can get and it can get very frustrating, Todd. I mean, I think the thing that's super exciting is, we're actively involved in some really exciting developments with Velo and the Sapphire machine that show incredible promise to the future, that are just in line with this fueling innovation. I mean, we're talking about technologies and product applications for our area in spacecraft platforms and propulsion that people have never seen before, and that's really what gets us excited at Interstellar every day, and has excited me throughout my career. But I really think it's going to find the public and generally the industry is going to find those types of advancements extremely exciting, because that's going to unlock domains like space and space tourism and space exploration in a way that we have not thought of possible before.
That's fantastic. That is some really out there thinking. So thank you for that. Now, Mike, I want to come back to you. So you're responding to your customers' designs. I'm going to ask a two-part question here. So how innovative have they been in the past with respect to using the liberties that additive provide? And then the backside of that question is, providing a supportless solution, have you seen them take advantage of that? Is it early days and they still have to learn what's possible and generate their own creativity, or are there people chomping at the bit and we're just waiting for the day like Jeff's team was?
Well, the first part of that question is, some of my customers are really taking additive seriously, and so they're designing new products with additive fully in mind. So in a lot of cases, these products, there's no other way to produce them. Basically, they're using additive to the fullest and taking advantage of that. And it's been real exciting working with some of our customers doing that. And then the other part of it, some of our customers are embracing the new technologies of using supportless technology and starting to develop and starting to put that into the designs and tweaking the designs, or when they have the ability to start from a clean sheet of paper, they're using this and they're excited about this and excited about the ability to use supportless design. So we're seeing both. And it's only getting more and more attractive to our customers. So it's exciting.
What typically happens in my experience? There's usually a spark within a company where somebody does something out there, and everybody else goes, "Wow," and follows suit. Have you seen that kind of thing there, where this is a little off topic, but it's one individual or one small team who pushes the envelope, succeeds, and everybody else?
Yeah, that's the way it traditionally goes. I mean, you have a small group working on something and they want to explore an alternative. A lot of times it comes out of desperation because they ran out of time and they needed a quick way to produce something. And so they use additive in the mindset that, okay, we got this for the prototype, but then when they really see it and understand it and see how it performs, they go, well, this is a manufacturing solution for this product. So yeah, I mean, a lot of it starts that way, but but then you have some companies that are focused and have put together great teams and within the supply chain that are really focusing and trying to do it methodically and step by step correctly. And so introducing it, in enterprise-wide.
Excellent. Yep, necessity is the mother of invention, but desperation is the driver oftentimes. So
exactly.
I love that you said that. Well, to round out fueling innovation, Jeff, you had one quote in the white paper: supportless AM is key to fulfilling the promise of additive manufacturing. You've talked at length on that. Is there anything you want to add? And if you don't have anything to add, I won't put you on the spot.
No, there's one more thing I think I'd like to add to what's been talked about already. I think we all look for a day where we realize that original vision of additive, where we print the part, we pull it out of the machine, and we take it to the test stand, or we take it and put it on the rocket, or we put it on whatever system we're talking about. And I think this supportless technology that we're realizing now is another step, and probably one of the key steps in that process, because I think that's what we all want. We want to have a finished part right at the end of print, including, all of the properties we're expecting, all of the proper interfaces, all of the proper surface finishes. And that's why I think the supportless AM is this key to fulfilling the promise of what I think a lot of us thought additive would be 10 years ago or more, and we're getting closer and closer to that all of the time. But these technical innovations in machines like Sapphire are really getting us where we all want to be.
Excellent. And I have to agree with Jeff on that as well, because getting into this 8 years ago, you have a mindset that, hey, just print and go. Well, it's not necessarily true. And but we're getting closer every day.
Well, kind of playing straight man, with what you've experienced with the support elimination metal additive process, what's the next big thing for you to tackle? What's the next big win for your businesses, if you care to share?
Well,
comment, a fine answer.
Well, developing more innovative products that take advantage of complex geometries, the designs and consolidation of products, we've touched on that a little bit, but I believe where this is going to head, the direction it's going to go, is where we can start taking advantage of combining products, eliminating part count, eliminating purchase orders for multiple pieces. We can start to really push the boundaries. And when you start combining parts, now you're starting to deal with a different variety of parts, different features. So supportless is going to aid in that, because you're not going to always have the perfect piece in that mix when you're combining components together. And I mean, I've experienced combining 25 parts into one, and there was challenges. And having supportless is going to be key for that, and it's monumental going forward, where we can apply this technology and push it to the next limit.
Excellent. Jeff?
Yeah, I think the thing that excites me, if you'll indulge me for a second, is we're all about the future at Interstellar, and so I think this technology first step is in where we're applying additive for reusable space systems that allow us to explore the solar system, and And so one of the reasons it's so critical to this conversation is if I'm orbiting the Earth or the Moon, or I'm on the lunar surface, or I'm out looking at resources on asteroids and I need parts, I need new things to happen. Very similar to the Star Trek replicator, I want to reuse that print capability to create the parts I need ready to go for my system for things that depend on my survival as well as furthering the mission. So I think in terms of space technology, we're really starting to crack the code. You see a lot of companies focused on all additive rockets, all additive engines, all additive this and that. But that's what gets us off the planet, and what we're focused on at Interstellar is the application of this technology to true exploration, beyond low Earth orbit and taking us farther out to expand humanity's knowledge and to inspire everybody involved in the process.
Excellent. Thank you. To wrap up, I'm going to turn the conversation over to Richard. Now, I'm just a few minutes beyond where I wanted to be. If you have a question and you need to depart, you can send your questions to info@velo3d.com. So if you need to depart promptly at 3, use that email address and we'll get back to you. So with that, Richard, invite you to put a recap on this for us.
Thanks a lot, Todd. Appreciate it. Jeff, I'm kind of bummed because I was really looking for an opportunity to slip in that Star Trek replicator metaphor somewhere, and you beat me to it. So, but I guess it's more appropriate given your industry anyway. So thanks for that. I think it's totally appropriate. At Velo, for us, it's really about choice. It's about creativity, the ability to build the parts that you need for real production use at scale and at volume with the quality, the reliability, the safety that is necessary for the application. And our forte is as you see here on the screen, it's these sort of macro-sized parts, if you will, about the diameter of a basketball hoop. They stand a little bit taller than the ball itself. Things like blisks, impellers, manifolds, heat exchangers, things with low angles, high aspect ratios, very, very thin walls, the kinds of features that have been challenging but very necessary in the parts that these industries require. You mentioned the spark, that sometimes gets things going, Todd. And if you look on the left-hand side of this diagram, there's an impeller, a specialized part there that we did a white paper on in 2019 that belongs to KW Micropower. And actually that part was conceived but could not exist without the capability to build it in an additive manufacturing capacity. So that's a great example. It's enabling an entire product line to exist that would not even have been possible before. So in industries like oil and gas and aviation and power generation, these things are massively important. They need to be produced as reliably as traditional manufacturing methodologies have been. And it's super exciting that we're getting to a point now where we can embrace being able to do this, whether it's direct part replacement or addressing the innovation requirements of demanding new designs. So looking forward to seeing how far we can push it and tackle the challenges as Jeff mentioned that would make it as easy as literally just pulling the part out of the chamber and bringing it into production.
Excellent, excellent. I love that word, enabling. Hopefully the conversation has enabled you to think a little more expansively, to build out your business case, to push metal additive further and farther within your businesses and your product design needs. So with that, I want to thank our panelists very much for a very lively and insightful dialogue, and thank all of our attendees for joining us.
Thank you for your time, and enjoy the rest of your day.
Thank you.
Thank you, Brent.
Thank you.